Hello, welcome to this video. So this is the sixth video in the Kubesphere series, and in this video we're going to take a look at how to provision a highly available Kubernetes cluster using kubekey, and we'll be using Keepalived and Haproxy to achieve the high availability setup. So for those of you who have not seen any of the previous videos in this series, just a quick recap of what we've been up to previously, right? So we've been playing with the kubekey tool from Kubesphere to provision Kubernetes cluster, and then we saw how to use Kubesphere to deploy a highly available Kubernetes cluster in the previous video. We also saw how to deploy Kubesphere on top of existing Kubernetes cluster and things like that. In this video, we're going to take a look at a proper HA setup using Keepalived and Haproxy, and let's see how we can use Kubesphere to deploy a highly available Kubernetes cluster with these two components. In fact, I did a video quite some time ago with exactly the same setup using Keepalived and Haproxy. So if I search in YouTube for just me Keepalived, and the video here, Kube 1.5, set up highly available Kubernetes cluster step by step using Keepalived and Haproxy, is exactly the same. So it's exactly the same process that we are going to follow, but instead of using my background scripts, we're going to be using Kubesphere's kubekey to provision a highly available cluster. But still, the Keepalived and Haproxy setup are going to be manual. They are going to be very similar to what I demonstrated in this video. So let's open up the Kubesphere documentation. So if I go to kubesphere.io and go to the documentation, the latest version as of recording this video is 3.3. And in here, we've been looking at the high availability configurations. On the left, we saw there were like 3 high availability configurations. This is the one we saw in the previous video, and I'm going to skip this setup here. So this one, basically, if you're using this in a cloud-based environment, then you can go with this option. So this is basically setting up a HA cluster using an external load balancer. So all you need is, in your cloud environment, you need to have a cloud load balancer, and you need to have the IP address ready in hand. And then the kubekey will provision a cluster using the load balancer's IP address. But in my case, I'm going to be using, I'm not in the cloud environment, so I'm doing all this in my local laptop bare metal. So I'm going to go with this third option. I'm going to skip the second option. It's going to be fairly simple. If you follow the steps, then it's going to be fairly simple. All you need is an external load balancer deployed in your cloud environment. Okay, so we're going to go with this third option for this, preparing the host. All right, let's see how the architecture will look like. Okay, so again, 3 master nodes, 3 etcd nodes, 2 Haproxy nodes. So these 2 nodes are going to be your load balancers. So in order to achieve high availability, we are not going to go with just 1 Haproxy node, but we are going to go with 2 Haproxy nodes. So we give a high availability setup not just for the master nodes, but also for the load balancer node itself. In fact, if you want, you can add more Haproxy nodes, load balancing nodes in this layer, but the minimum, as you know, is just 2. And we run this Keepalived process. That's the one that takes care of assigning this virtual IP address. So we will have a virtual IP assigned to one of the load balancer node, and the Keepalived process on each node will talk to each other to see if the nodes are alive. So if this node goes down, the Keepalived process won't receive a heartbeat from this node. So this node will assume the other node has died. So it will take over the virtual IP address. The same is the case with the other node. So there's a constant heartbeat communication between the Keepalived process between these 2 nodes. So if either of these nodes doesn't receive a heartbeat from the other node, then that node will pick up the virtual IP address. So that virtual IP address is just an alias as a secondary IP address. And again, all the worker nodes, they communicate via the virtual IP load balancer to the master nodes. All right, so that's about the architecture. What we'll be doing in my setup is I'm going to go with 5 virtual machines. All right, I have to go with 3 master nodes, so I'm going to go with 3 master nodes, but instead of 3 separate etcd nodes. Bear in mind, if you want to achieve a true highly available cluster, you need to separate your etcd nodes from your master node. If a master node goes down, it will also take an etcd node with it. So it makes sense to put etcd cluster in a separate set of virtual machines. So each of these etcd nodes will be in its own virtual machine, forming a cluster outside of the master node, outside of the control plane cluster. But because I'm running this all on my laptop, I don't want to spin up too many virtual machines and cause stress for my laptop. So for this demonstration, I'm going to be using 3 master nodes, and I'm going to be using the same set of master nodes for etcd as well. So each of these master nodes will be running an etcd process as well. well. All right, and I need to have 2 Haproxy nodes. So again, it will be 2 virtual machines. I'm just going to go with just 1 worker node just to show you how this Hache setup will look like. So in my case, it's going to be 3 master nodes, 2 Haproxy, and 1 worker node. And I've put all these together in a Vagrant file, and I'll be using that to provision my virtual machines. All right, let's go back to the terminal. And I'm going to git clone my Vagrant repository. I'll put a link to my GitHub repository in the video description if you want to download. Okay, cd to Vagrant. And in here, I'm going to go into Vagrant files. And in here, I've got a directory called Kubesphere. And in here, I've got the Kube 113.6. That's the title of this video. For the previous video, 113.5, the Vagrant file and the bootstrap scripts will be in this directory. So let's go into Kube 113.6 and take a look at what we have. So I've got a bootstrap script and I've got a Vagrant file. Let's take a look. Right, so the Vagrant file, it's very similar to the Vagrant file that I used in my previous video. If you take a look, I'm using Ubuntu 20.04, Vagrant box version is 4.2.6, and as I said, I'll be using 3 master nodes, 1 worker node, and 2 load balancer node. And for the load balancer nodes, I'm going to be using 1 CPU. All it's doing is just running a Haproxy and Keepalived process, so there won't be any workloads running in the load balancer node. So I'm going to keep it lightweight, assigning them 1 CPU each and half a gig of RAM. And for worker nodes, I'm going to be going with 2 CPU, 4 gig of RAM, and same with the master nodes. All the master nodes will get 2 CPU and 4 gig of RAM. So I've got 32 gig of RAM and 24 cores of CPU on my laptop, so it should be sufficient for me to run all these 5 virtual machines. And the provider blocks here is all the same like in my previous video. I've got the VirtualBox provider as well as the libvirt provider. If you want to use VirtualBox provider, you can use it, and I'm going to be using libvirt in my case. All right. So again, let me show you my bootstrap script. All it does is it sets up the password authentication. By default, Ubuntu disables the password authentication, so I'm enabling that. And I'm also permitting the root login. By default, root login is disabled. I'm enabling that. And I'm setting up the root password to be admin, and I'm installing socat and contract package. So if you've been following all my previous videos, the 2 prerequisites for running Kubernetes using Kubesphere is these 2 packages, socat and contract. I don't want to be running this on every single machine, so that's why I've put this in a bootstrap script. So when I do Vagrant up, it will get installed on all the virtual machines. All right, let's close this one and do Vagrant up, provider libvirt. Right, so it's going to take about a minute or 2, and it's going to provision 5 virtual machines. So once this is up and running, I'll be back. Okay, so the Vagrant up command completed, and if I do Vagrant status, so we should have 5 virtual machines: master 1, master 2, master 3, worker 1, load balancer 1, and load balancer 2. All right, so let's go back to the documentation, and the first thing we're going to do is the IP addresses. I wanted to show you the IP addresses. All the master nodes, the IP addresses will be 172.16.16.101, 102, and 103. And if I scroll down, for the worker nodes, it will be 172.16.16.111, 112, 113, and so on. But in our case, we are just going to go with 1 worker node, so it will be 111. And for load balancing, it will be 172.16.16.121 and 122. All right. Cool. Alright, so we've got our hosts set up, configuring the load balancing. Alright, the very first setup we'll be doing is to install Haproxy and Keepalived. So this one is an yum command. This is for an RPM based distribution. So because we are running Ubuntu 20.04, we need to be using apt to install this. Again, I've checked in Ubuntu, this package psmisc is already installed. So all we need to do is just install Keepalived and Haproxy. So let's do that. We need to do this on both the load balancing nodes, load balancer 1 and load balancer 2. So I'm going to open up another pane, and I'm going to go into the same directory, do Vagrant SSH load balancer 1 on the top pane, Vagrant SSH load balancer 2 on the bottom pane, and I'm going to synchronize the 2 panes. So when I type the command on one pane, it gets typed on the other pane as well. So I'm going to become a root user now. Alright, so apt install Keepalived and Haproxy. Okay, so that's installed. Let me clear the screen, go back to the documentation. First thing we'll do is we will add the configuration for the Haproxy. So it should be under etc haproxy config. Right, so we have the default configuration. I go all the way to the bottom, insert new line, and then I'm going to copy just the front end and the back end block. Copy, and I'm going to paste that here. All right, so we've done that, and what I need to do is, if you look at the IP addresses, so that's the front end Kube API server. It listens on port 6443. So traffic coming to the port 6443 on this load balancer will be directed to one of the three backend servers, Kube API server 1 to 3, and we need to change the IP address, right? So our IP address is 172.16.16.101 to 103. So I'm going to change that to 16.16.101, and here 16.16.102, 16.16.103. all right, so that has also changed in the bottom pane, so we are good. 172.16.16.101, 102, 103. So those are the IP address for my master nodes. Let's save that, and we just need to do systemctl restart Haproxy and systemctl enable Haproxy. I know the Haproxy service, when we install, it's automatically enabled on Ubuntu machines. If you are running this on CentOS or Red Hat, then you need to enable it. It won't be enabled by default, I guess. All right, let's do systemctl status Haproxy. Yeah, that's running fine. Now let's proceed to the Keepalived configuration. All right, so this is going to be an empty file. It won't exist. So we are going to create one, etc keepalived, keepalived.conf, and I'm going to paste this. We need to change the configuration slightly. If you look in here, so interface is ETH0, but in my case I'm going to be using ETH1 interface. I'll show you why. Right, let me first close this one. If I show you IP address show, so you have the localhost ETH0 and ETH1. If you look at the IP address 172.16.16.121, 172.16.16.122. So those are the IP address for the private Ethernet network interface that my vagrant script provisions. So I don't want to be using ETH0. I want to be using the ETH1 interface for all my Kubernetes traffic. So in order to use ETH1 interface, I need to change the Keepalived configuration to use the ETH1 interface. The unicast source IP is the IP address of my load balancer machine, the IP address of this machine, and the unicast peer is the other load balancer node. All right, so we need to change that, and we're also going to assign a virtual IP address. Right, let's copy this and change it accordingly. Right, so copy, open that file. Right, I'm going to save this. I'm going to turn off the synchronization because I need to change the IP address on each node one by one. So I'm just doing this on the load balancer 1 first. So let's search for ETH0, and I need to change this to ETH1. Okay, and if I scroll down, unicast source IP, so that's going to be the IP address of this machine, which is 172.16.16.121, and then this is the IP address of the other load balancing node, 172.16.16.122. Right, that's fine. And here I'm going to change the virtual IP address to 172.16.16.200. Right, so our virtual IP address is going to be 172.16.16.200. So that's the API server IP address that we will be using in our cluster. That's all we need. So change it, save it, and do the same thing on the load balancer 2 node. Search for ETH0, change that to 1. Unicast source IP address, this one is going to be 172.16.16.122 because this is load balancer 2. And this one is 172.16.16.121, and we need to change the virtual IP to 172.16.16.200. All right, let me turn on the synchronization back. Okay, so we've done that. Again, we need to restart Keepalived, and we also need to enable the Keepalived service. Cool. So now if I do hostname -I, you can see 172.16.16.122. So that's the IP address of load balancer 2. 172.16.16.121. That's the IP address of load balancer 1. And in addition to these two IP addresses, you also see the virtual IP address. So this is the virtual IP address which is assigned to load balancer 1 at the moment. Right, if I do IP address show, you can see for the ETH1 interface, there's a secondary IP address attached. So the Keepalived process takes care of assigning the secondary IP address to the ETH1 interface. So at the moment, ETH1 interface on load balancer 1 has got this secondary IP address. Right, so now it's time to verify our high availability setup. So what is recommended here is to stop the Haproxy. You could either stop the Haproxy, as I shown you previously. The current virtual IP address is being served by load balancer 1. I could either shut down this load balancer node, or I could just stop the Haproxy, right? Systemctl. No, I don't want to stop Haproxy on both the nodes, so let me disable synchronization. Systemctl stop Haproxy. So Haproxy is not running there, right? If I enable synchronization and do hostname -I, and now you can see the virtual IP shifted to the load balancer 2 node. All right, cool. Right, so let me turn back systemctl start Haproxy service. All right, so we verified our Haproxy nodes, and the virtual IP jumps between the load balancing nodes depending on which one is actually available. So make a note, currently we've got the virtual IP address assigned to the load balancing 2 node. All right, so let me exit out of the load balancing nodes. We don't need them anymore. All right, so our manual steps are all done. Keepalived and Haproxy on the 2 load balancing nodes. So now we are going to use, which you've seen in all my previous videos, we'll be using the kubekey to deploy a Kubernetes cluster. So the first thing is to download the kubekey binary. All right, so that's downloaded, and the kubekey, the executable bit is already set. If not, run this command change mode +x kubekey. And the next thing we'll be doing is create a cluster configuration file. Right, with Kubernetes version 1.22.12, I'm not bothered about changing the version of the Kubernetes. All I want to show you is how the HA setup works. So it doesn't matter which Kubernetes version I'm going to go with. Also, I'm not going to deploy Kubesphere. I just want plain Kubernetes cluster. If you want, just go with Kubesphere, but it's going to take extra time to set up the cluster, to deploy all the Kubesphere, things like that. So it's not going to affect the HA setup in any ways. So we'll just go with just the Kubernetes cluster for this demo. That's done. And if you take a look, there's the config sample.yaml file that got created. So we are going to edit that file. And the first thing we're going to do is we are going to update all our host configuration, and then we will add our load balancing nodes IP address, virtual IP address. That's the VIP, virtual IP address, under the control plane endpoint section. All right, let's go and do that. Okay, so I'm going to delete that, and this one will be master 1, and master 1's IP address will be 172.16.16.101, and again the same IP address for internal address as well, 16.16.101, and the user is root, and the password is admin. All right, so I'm going to copy that and paste it 5 times. 2. This one is master 3, and this one is worker 1. This one is load balancer 1. This one is load balancer 2. Master 2's IP address is 102. Master 3 is 103. Worker 1 is 111. Load balancer 1 is 121. Load balancer 2's IP address is 122. Again, it's all the same for the internal IP address as well. 172.16.16.122. 121. 111. This one is 103, and this one is 102. I think I've got everything right. Master 1, Master 2, Master 3, Worker 1, Load Balancer 1, Load Balancer 2, 101, 102, 103, 111, 112, 112. Yes, I think I've got everything right. and the username and password is going to be the same for all the nodes because we've done that through the Bootstrap provisioning script. Alright, so our HCD nodes is going to be master 1, master 2 and master 3. Again, these are going to be the same for the control plane, and for worker node we just have one worker node, worker 1. Okay, so we've done all that. Under control plane endpoint, we need to add the virtual IP address. Alright, so the domain lb.kubesphere.local will be pointing to this IP address 172.16.16.200. So that's the virtual IP that floats between our Haproxy nodes, if you remember. Alright, so we've done that. Save. And all we need to do is just start the installation by running this command, create cluster, and pass the configuration file we just edited. Alright, so let's do that. And it's going to take a little while, so I'm going to pause the video and come back when it's done. So it's asking for confirmation. Let me type yes. Right, so see you shortly. Alright, the command completed. It took about 5 minutes, less than 6 minutes. Okay, so what I'm going to do now is vagrant SSH worker 1. So let's log into one of the worker nodes, become root user. I can do kubectl cluster info. There we go. So API server is up and running on lb.kubesphere.local. So if I do host lb.kubesphere.local, you can see it's pointing to our virtual IP address 172.16.16.200. kubectl get nodes. So we have 3 master nodes, all of them are ready. Worker node version 1.22.12, kubectl get pods -a. So I think all the pods are running fine. So we've got a working Kubernetes cluster. What I'm going to do now is going to open up another pane and go to the vagrant directory. If I do vagrant status, so we want to test the high availability configuration, right? So back in here, I'm going to run a watch command, kubectl get nodes. So this is running kubectl get nodes command every 2 seconds. So we just want to verify the high availability setup. So we've got high availability configured because we've got like 3 master nodes, so anyone can go down and still we should be able to access the Kubernetes cluster. And again, we've got 2 load balancing nodes. Again, there is a bit of high availability setup for the load balancing layer as well. So if you recall, then we have the virtual IP currently assigned to load balancing 2 node. If I go to vagrant SSH load balancer 2 and do hostname -i, you can see 172.16.16.200, which is the API server address, and that's assigned to the load balancing 2 node. What I'm going to do is let's take the load balancing 2 node down. All right, let's assume that the load balancer goes down. So I'm going to do vagrant halt load balancer 2. So this should shift the virtual IP to the load balancing 1 node. So let's go to vagrant SSH load balancing 1 node. By the way, you can see on the left we didn't drop any connection. The connection to every single connection to the API server is going through fine. So we are in the load balancing 1 node, hostname -i, and you can already see the virtual IP address shifted from the load balancing 2 to the load balancing 1 node because the Keepalived process between these 2 nodes talk to each other, and the Keepalived process in the load balancer 1 node found that it didn't receive the heartbeat back from the load balancing 2 node, so it picked up the virtual IP address, assigned it to itself. Alright, so that's how it's actually working. That's fine. And again, let's take one of the master node down to see if we can still access the Kubernetes cluster. Vagrant halt master 1. So it's attempting a graceful shutdown, so it's going to shut down all the process. It's going to attempt a graceful shutdown, not a hard shutdown. So it's going to take a few seconds here to completely shut down the master 1 machine. And once it's done, you will see on the left here, the status of the master 1 node will go from ready to not ready. But still, the point is we should still be able to access our Kubernetes cluster with 1 master node being down. So I don't want to take more than 1 master node down. because when you see in a cluster of 3 master nodes, if one node goes down, you would have set up all your monitoring and things like that, so you would be alerted when a master node goes down. So you should act upon immediately and try to bring back that master 1 node up as soon as possible, and don't leave the cluster with 2 master nodes. It could lead you to a split brain situation. So it's very dangerous to leave a cluster with 2 master nodes. So as soon as you see one master node going down, just work on it, fix it, and then bring it back again. Alright, so the node is completely down, and you can see on the left here the master 1 status has become not ready, but still we didn't drop any single connection to the API server. So every single kubectl connection from this node goes via the load balancing node. Again, we have just one load balancing node. We should try and bring the other load balancer up as soon as possible, but still this load balancer is serving the traffic to the 2 master nodes, master 2 and master 3. So our setup is perfectly valid. This is all I wanted to show you. I hope you enjoyed this video, and I think that's all for this video. I will see what I can do for my next video in this series, or I will jump on to other concepts in Kubernetes. Alright, thanks for your time watching this video. I will see you all in my next video. Until then, keep learning and keep on learning. Bye bye.